Since I can always cut it out.
Yeah, it's on your phone.
What? You should get up there. Why? You should get up there. Why? You should be the teacher. Oh, actually, no. Yeah.
Okay. Can you hit play, I guess? All right, ready? So today we'll be discussing properties of limits. Okay, so today we're not ready just yet to do algebraic limits. Cool. Some of you guys already feel comfortable with that, so you have experience with that. Again, I'm not gonna penalize you for knowing more than where we're at in the course. You can utilize it. But for those of you guys that you're like, okay, this is brand new, this idea of limits, before we can get to the algebra, it'd be very helpful to know how I can manipulate expressions. And in order to do so, these properties are gonna be very helpful. Fair enough? So, first I'd like to start with just a simple graph to make sure you understand why one of the things that I'm gonna start with makes sense. So if I give you the function y is equal to x, we know it has this type of behavior-ish, right? So hypothetically, like let's say that this value here is c. Doesn't matter what it is. I could have put it on this side, it doesn't matter. Cool. The first property that we need to learn is, what is the limit as you approach c of x, which is known as the identity function. Cool. Now, here's a graphical representation of x. So I want you to think this through. Even though I don't know what the value of c is, it's just x approaches c, I should still be able to obtain a limit for this. What would it be? C. Why? Because y is equal to x. So if x is 5, then y is 5. If x is 2, then y is 2. If x is -5, then y is -5, right? So essentially what it's saying is like, this point right here would also be c. Because y is equal to x. And as I approach from the left and I approach from the right, I am arriving at that location. Fair enough? So would it be crazy for me to say that the limit as x approaches c of x is equal to c? And that will always be true for any value of c, right? Fair enough? Okay. Statement number 2. If I take the limit as x approaches some c value, but now let's say we have k. All right, your first question is like, what is k? So just for this problem, let's just say k is an element of the real numbers. Cool? So just a real number. I don't have the graph of that, so I'm just gonna add a graph of that into what I currently have. So, I don't know. Would you agree that if I have something that is just y is equal to k, is simply a horizontal line at that value of k? Once again, I want you to look at this carefully. Now I'm going to ask you, what is the limit as you approach c, here, for that specific function? K. It's got to be k, because that's going to be this value right here. And this is y is equal to k, then this value has to be k. Agree? So, these two things are one of the things we're going to use the most when we get to the algebra portion of this. To summarize, the limit as x approaches c of x is always the c value, and the limit as x approaches c of a constant is always the constant. Make sense? Graphically makes sense why we're doing this? Okay, perfect. Now, the rest of what I'm about to discuss are literally just more like what the textbook wanted to discuss. This is something that I added. There are properties of limits, and it really just comes down to the ones that I'm going to show. Cool? So there's something called the additive and the subtraction property of limits, which means if I have a limit as x approaches c of some function, and then I'm either adding or subtracting another function. Cool? But the key here is notice how I'm taking the limit of both. The parentheses are totally necessary. The way that you can approach this problem is that you could actually break it up into two separate limits. You can take the limit as x approaches c of your first function, and then you can add or subtract the limit as you approach c of the separate second function, and then add those quantities. Cool? Now, when we get to the algebra, and once you actually get more experience with this, you might be like, okay, that was kind of silly to do. So you might not want to use it a lot, but what I'm trying to show you is that this is something you can do. Fair enough? Okay. If you can add and subtract, then you can probably multiply and divide. Cool? So, limit as x approaches c of f of x times g of x. Would you care to guess what you can do?
Separate them.
Separate them into two limits that are being multiplied. Easy enough. Go ahead and write the fifth one, which would be your division. Okay, I'm gonna write this down since there's a video about this, and I'm not sure everyone knows this. But when you're dividing, we need to make sure that you know that there could be a problem when dividing. What would that be?
0.
If the denominator is 0, because I cannot divide by 0. So technically speaking, like if I want to be very, very thorough, this could only be true as long as the limit as x approaches c of g of x does not equal to 0. Okay? Now, before I keep going, we keep going, I want to discuss that right now. Because that's going to be one of the things that's going to happen the most when we start getting to algebra. You're going to have some type of division, and then the 0 might show up on the bottom. Okay? Now, before we even get to the algebra, I want you to think this through. You've studied Algebra 2, you've studied graphing, and a lot of topics prior to getting to this topic. What would it mean graphically if a 0 is showing up on the denominator of a function? Some type of asymptote, specifically what type? Vertical asymptote. What else could it be? A whole. So in other words, we discussed this last class, discontinuity. If I'm dividing by 0, there's gotta be a discontinuity somehow. Question, could there still be limits even though there's a discontinuity? Yes, and that's what we discussed last class. So just because I'm getting a 0 in the denominator doesn't mean I'm just gonna be like, oh, okay, this doesn't exist, I'm moving on with my life. Cool? Now, at this point I wanna get a little ahead. How would you know, okay, let's say you're doing your math and you're dividing by 0. How would you know if it's a whole or if it's an asymptote?
If you have the same thing, if you can cancel it out on the numerator.
Remember, in Algebra 2 you were taught how to find wholes. And in order to find a whole, you would have to have a common factor on the numerator and a common factor on the denominator. So what would really happen, and again I'm getting ahead of myself, is that if you're taking this limit, you're gonna get a 0 on the top and you're gonna get a 0 on the bottom. If you're getting that has a name. We'll discuss that next class, but really I'm just gonna go ahead and tell you, you know what that is. That's a whole. Can there be a limit at a whole? 100%. We'll discuss how to get there next time. However, let's say you get any other number other than 0 on the top, but you do get the 0 on the bottom. So then at that point, then what are you dealing with? A vertical asymptote. Now, think about all the experience you have with graphs. Is it likely that the limit is going to exist when there's a vertical asymptote? No, most graphs end up doing something like this. Most graphs, right? Could I still do something like this? Yes. So, could I technically have a limit? Yes. Unlikely. Very unlikely, but you can still have it. Fair enough? Okay, yes?
But even if it goes like this, wouldn't it still be like an infinite limit, so it would technically not be, but like graphs?
Beautiful. So, thank you for bringing that up. So, technically, like some textbook, and then some mathematicians agree with this, some of them don't. So, the idea is the definition of a limit says that as you approach x arbitrarily close from the left and the right, you're approaching a specific value. if they're both going up, I cannot consider infinity as a value. So technically speaking, like the correct way according to that definition is for us to say that it doesn't exist. However, it's helpful to know that they're both going to infinity, and I'm gonna go ahead and tell you this, since you are gonna be taking that AP exam, hopefully, they're gonna want you to know that that is going to infinity. So I would encourage you to say infinity rather than does not exist. Fair enough? Okay, are we good so far with our operations? So basically all so far we've discussed is your basic operations that you've learned in grade school, right? Okay, what else could happen? All right, so, sure I'm skipping. Let's say we have something like this. So let's say you have a function to a power. Like pretty simple, like let's say I gave you like x squared, all right? Technically speaking, you could do the following. You could take the limit of the inside function, because I could consider this to be a composite function, and then take it to a power. So as silly as it sounds, like for example, if I had limit as x approaches x squared, I could take the limit as x approaches x, and when I get the answer to that, square. Cool? You're gonna, once we get practice with the algebra, you're gonna be like, that's very silly. I agree. But the reason why whatever we're gonna do next is gonna work, it's because of this. Fair enough? Now, the next one has, to me, is the same thing as 6, but I'll go ahead and write it. If you have the limit as x approaches c of some root of a function. Why am I saying that 6 and 7 are basically the same thing?
One over x.
Remember that a root can be written as a power, right? So essentially, if you do want to keep it as a root, which I will do it for this one, if you notice what I did with 6 was take the limit and then take it to the power, then what I should be able to do is take the root of that limit. Make sense? We're doing okay so far? Okay. Look, along these lines, I can keep writing more and more properties. Like for example, like I could take the log of a function, right? So then what do you think I would do? Take the log, and then the limit on the inside of whatever happens, and then take the log of it. Does that make sense? So, I mean, what I'm trying to show you with this, like, at least this last two, is that you can basically focus on what is happening on the inside of a function, and then either take the log, take the square root, take whatever else is an absolute value, whatever is happening. Fair enough? Okay, but then here's this last one. I need you to put a star by this one. Limit as x approaches some c value of f of g of x. Okay, so this is called a composite function, which, do we remember what that means? Yes? So in this case, that means that I input the function of g into the function of f. Agreed? Okay. This was kind of tricky to kind of write it as a rule, so it's kind of be like, I'm gonna write it kind of like in steps in order for you to be able to do this. First, you need to figure out what the limit is as you approach c of the inner function. Okay? Why would I have to do that first?
Put that into the
Think about it. Isn't that what you put into the other function? Like you gotta put that into the other function? Okay. Well, right now, I mean, I'm not dealing with numbers. So let's say it does exist, right? So it's gonna give me some value. Agreed? So I'm just gonna call it L for limit. Fair enough? So I took this limit as x approach c of the inner function, but I got a result of L. Okay. What do you think I have to use, or what do I do now that I know that it approaches L?
Plug and
put
that
that
back
in.
in.
Remember that a composite function essentially is, I'm gonna put in something into G. G is going to produce a Y value. That Y value is gonna go into F, which is now an input, so that that can produce something else. Now that's a function, right? For a function, you input a number, For G gives you an output. That output becomes the input of F. That gives you an output, and it's a point, right? But we're not doing points. What are we doing? Limits. Remind me of the definition of a limit.
Approaching composite.
So I don't care what's happening at L. What do I care about? How am I approaching L? But in order for a limit to exist, what must be true?
Both points must be the same.
You have to approach it, yes? And it has to be the same from what sides though?
Left and right.
From left and right. Okay, so this is where it gets a little tricky, so stay with me. I took this limit, I looked at the behavior, it was left and right, you guys with me? And it got me L. That's why I said L, right? This is an output, right? This is a Y value. But isn't this Y value going to become an X value for the F function? Well, then before I can proceed, I need to make sure I check what happens with this value as far as, and I know this is gonna sound weird, top and bottom. Why? Because it's for the Y. What is that Y gonna become? An X. So if I need to check what happens top and bottom, when I switch to X, it's gonna become left and right. And I need to check for that because I'm gonna have to take a limit. Because I don't care what's happening as L, I don't care about what is happening as I approach L. So, that's a little tricky, it's kind of hard to, it's always difficult for me to kind of write this. So, I put this little thing to remind myself. I need you to do one-sided limits. We obviously know that if they both give you L, right, then the limit overall is L, right? But what I need you to check is the following. I need you to check if that L is coming from above. Above means numbers that are higher. Numbers that are higher will be positive. If it's coming from above, and I'm just making this up right now, you will put a little plus here. Cool? If you're approaching it from below, then you're gonna put a little negative here. Are you guys with me? Now, I'm making this up right now, I don't have any functions. If, when you take the one-sided limits, you obviously get the same value, and also one that's coming from above and one that's coming from below, then you can safely proceed to take this limit. L. Why? Because there's a left and there's a right. Does that make sense? But now of what function?
F.
Of F. You with me? Any questions so far? And we will do examples for this. Now, someone asked me this in the earlier class, and I'll go ahead and address that now, but I will also address it with an example. And well, Karen, what if I do this and I get a positive here, but I also get a positive there? Well, that means that as you're approaching that limit, if you're only getting positives, that means it's only coming from above, right? Does that mean that I can stop? The answer to that is no. What's gonna be the difference is because these are both positive, when I get to this step, then that would have to be positive. If they're both negative, then that would have to be negative. But if you have one of each, then you take a regular limit. Make sense? Good, how we doing? That is that is the content of it. Like, that is what today is about. These are the properties of limits. Now we're just gonna do a few examples to make sure you understand. Cool? Now, it's obviously you're gonna need more practice than what I'm gonna do in class, but definitely, like, that is the content for today. That's it. Fair enough? All right. Do y'all need a little bit more time to write it down? Ready? All right, so I'm gonna erase this part. I'll leave that up there. All right, I'm gonna be honest with y'all. I'm sweating because it's like, I know I'm being recorded. Like, I'm serious. Camera adds that pressure, man. All right, here we go. example number 1. Okay, so first, what we're gonna do, honestly, is I'm never gonna ask you to do this again. It's just kind of a way to kind of see if you're understanding how to apply the properties. Cool? So I'm gonna give you a limit. So the limit as x approaches c of the following. Okay. Technically speaking, because I didn't give you any instructions, it's like I'm almost asking you to solve this limit, right? It's like, that's really what the question is, right? I don't need instructions. It would just be like, what is the limit as x approaches c of this, right? I don't have any functions. I don't know how to do this. You with me? What I want to ask you to do right now is not necessarily what is the limit. I want you to use the properties that I erased and whatever's on the right there to make this one limit become as many limits as you possibly can rewrite it as. Cool? I'm never going to ask you to do this again. I just want to make sure again, you know how to do this, because when we get to the algebra, this skill would be very helpful. So, we'll do this together. I'll take your feedback. What do you think? How can I take this one limit and write it in as many possible limits as I possibly can? Give us one or something to do.
You can, for the additions, you can just do like the limit of as x goes to c of 3 of x and as goes to
Okay. I will do that eventually. Let's look at bigger picture first, but yes, bigger picture, yes.
You could use the fifth property of limits to split into two
Divisions, right? Now, I'm gonna be honest with you. You guys are my BC. I know you guys are super smart. You don't need to do it step by step the way I'm gonna do it, but just so that no one gets lost, I'm gonna take it a little bit step by step, and then you decide how many steps you can skip. I don't really care. You guys with me? So you say, big picture, I see a division. So by division, I should be able to split this up into the limit of the numerator, limit of the denominator. Fair enough? All right. So limit x approaches c. The numerator is the square root of 3x plus f of x. Denominator, limit x approaches c, x, g squared of x. Okay, perfect. Any questions on that one? Okay, now what would you suggest from here?
For the top, you can just make it like the square root.
Okay, so square root, so like it's like I'm taking the square root of the entire thing. Okay, of what?
Limit as x goes to c.
I'm gonna go ahead and do what you suggested earlier, so I can do 2 steps at once. Not only am I gonna take the square root, but now I'm gonna split that up into 2 limits by addition. Fair enough? Okay, so limit x approaches c of 3x plus limit x approaches c of f of x. Make sense? We're good so far? All right. I'm lazy, I don't want to rewrite this, so let's go ahead and apply some properties at the bottom as well. What can I do in the bottom?
Separate them into limits x approaches c of x times limit x approaches c of g squared x.
Okay, so I got that one times that one. Good so far? Anybody lost? Okay, perfect. Denominator, can I do anything else?
Square of g.
I could technically, yes, because this is square, I could take the limit of g of x and then square that. Agreed? So denominator, I would leave the limit as x approaches, well, actually, hold on. I'm gonna skip it, I can do more.
Square of both sides.
Hold on. This is a property I gave you.
C.
Oh, c.
The limit as x approaches
Yes,
c of
C.
x is,
C.
so I'm gonna be able to replace this with a c. And I can replace this exactly how you said, which is now I can just take the limit of g of x, but then square that. So limit x approaches c of g of x, and then square that. Make sense? Personally, the denominator, do you think there's anything else you can do? No. We're good. All right, numerator. The square root, there's nothing to do with it. Let's leave it alone. Look at this limit.
3c.
Okay, so you mentioned something I want to discuss. You said take the 3 out. You've done calculus, right? But let's discuss what that means. So what he's saying is he wants me to put this 3 in front and just say 3 limit as x approaches c of x. Agreed? Well, let's discuss the properties that I gave you to see if he's right. I'll go ahead and tell him he is right. But what is technically happening here between the 3 and the x? They're multiplication. Is there a property for multiplication that I gave you? So then wouldn't that essentially become the limit as x approaches c of 3 times the limit as x approaches c of x? So real quick before I keep going, what did we say the limit of a constant was? The constant. So as you gain more practice, for those of you guys where this topic is new, you can actually, instead of thinking of doing what I just did here, if there is a constant that's being multiplied, you can just think of it as like take out the constant, because it will always happen because of this property. Fair enough? So I ran out of space, so I'm just gonna go ahead and say, okay, this, we know the answer is 3, right? But I gotta be honest with you, we actually know the answer to this one as well.
C.
The limit as x approaches c of x is c. So I'm gonna go ahead and say that this becomes 3c. Yes?
So is that something we can always do, like since it's 3c inside, like it would become 3 times the c?
Yeah. Because, for example, and again, we know it's linear. You with me? Okay. And then lastly, there's nothing I can do with this limit, right? The f of x, so I would leave it as the limit as x approaches c of f of x. And I would say that this would be my final answer. Nothing else I can do. Agreed? Okay. This seems like a silly problem. It doesn't seem like we did anything. Did we actually even solve the limit? No, there's still, like, by the way, how do you know that you've done the limit? This word should not even be there anymore. If the word limit is still in your problem, you haven't found the limit. By the way, I'm telling you that because every year I get students that have not taken the limit and they're lazy, they don't want to write the word limit. That's wrong. If you stop writing the word limit and you haven't taken the limit, you are basically telling me that the limit is whatever you wrote, which is not yet. Does that make sense? Notation is going to matter. All right. Are we good so far? Okay. Now, let's add to this. Let's say that I gave you this problem. That's what we started with. And I actually want you to solve it. But so far, again, you don't know any algebra. All you know is tables, graphs. But let's say that instead I tell you, hey, the limit as x approaches c of f of x is equal to 2. And the limit as x approaches c of g of x is equal to, I don't know, -1. Can you now solve that limit?
Yeah.
Now what would you do?
Plug it in.
You will substitute this right here with a 2. So then it will become 3c plus 2. And this will become c times,
Well, technically,
yeah, 1, because it's -1 squared. And then at that point, would you say that it has been solved? Yes, because the word limit is done. Now, some of you guys may be asking, like, how do you know this? I don't know, I just made this up, guys. This is just data that I gave you. I'm not asking you to prove. You may just be given either by myself or the AP exam. They'll be like, hey, here's his limits. That's where they come from. It doesn't matter. I'm telling you, here's what it is. Utilize this data to solve a bigger problem. Cool? All right. I need feedback from you. Do you feel like you need another example of something like this, where I give you data and you solve? You feel comfortable with that? All right. So the homework, there's definitely a whole bunch for you to practice on that direction. Okay. Here's what I'm worried about. This bad boy. This is the one that I'm definitely gonna talk more about. Okay. So one last time. You feel good with this type of problem then? Okay. So.
Wait, Mr. Taylor?
Yes.
Sorry, they'll typically give us the limit, right? Instead of just giving us like f of x is equal to this. So,
Well, based on where we're in the course, I'll give you this. but you're asking me they. They, at that point, you have covered all calculus. So they could give you a table, they could give you the function, they could give you a graph, they could give you this, so they could give you a whole bunch of things, because by that point you will have more tools under your belt. Does that make sense? And I'm gonna be honest, the same goes for me. By the time you take the test, you will have seen more ways of finding limits, so I could also give you a table, or a graph, or this. Cool? Alright, so okay. Sample 2. What is the limit as x approaches to of x minus 1 squared? Cool? Alright. First, I didn't even give you a table. I didn't give you a graph. That's the only way you know how to do things, right? But more importantly, based on what we're doing today, would you consider what I gave you a composite function?
Yes.
Yes. If you need to do this, and you need to do this, if you were gonna write it in the form of f of g, which is this, right? Can you tell me what f is, and can you tell me what g is? F of x would be what? X squared. And g of x would be
X minus
x minus 1. For those of you that guys that having freak out, I don't know if you remember this. At the beginning of the year, I asked you to do the idea of decomposition. Now you're in the reason why. Here's the reason why I asked you to learn that. Because of limits, and then eventually you're gonna see there's this thing called the chain rule. When we get there, you're gonna really understand even more why. Okay? This is important. You need to be able to decompose a function. Okay. According to what I have written down there, what am I supposed to do?
Find the limit as like x goes to c from negative and positive.
For what function in this
G
case?
of x.
G of x.
Which in this case, you guys were saying that that's the linear function, right? So, then you're asking me to find the limit as x approaches 2 from the left of x minus 1. I'm also asking you to find the limit as x approaches 2 from the right of x minus 1. Fair enough? Again, we don't know the algebraic way yet, so I'm gonna skip that part. If you know it, you can do it that way, but all you know is how to do this graphically. I picked an easy function so that you could graph this. Do you know what x minus 1 looks like graphically? Slope of 1, y-intercept of negative 1, which means if I'm at negative 1, this is also 1, so then it looks like something like that ish. Yes? Okay. What am I being asked to approach? 2. So here's 2, here's some value. What value is that? 1. Agreed? So, as I approach this from left and right, am I going to a specific value?
Yes.
So the limit is definitely gonna exist. But remember, I need to check one more thing. Cool? So, from the left, which is this side, as I am approaching this valley, I am arriving at 1. But here's the question that you need to ask yourself. As far as the outputs, which are the y values, as you're approaching this output of 1, are you approaching it from above or from below? Below. Which means you need to put a little negative here. Why the negative? I want you to think about it. What kind of numbers are underneath the negative numbers? Okay. As you're approaching this 2 from the right side, you are coming to 1 again, but where are you approaching it from? The positive values. Does this make sense? The fact that you got a negative and a positive allows you to do what? Find the limit as x approaches what? 1. I don't need to worry about left or right because I got a positive and a negative. Of what?
G of x,
Which happens to be
x squared.
x squared. Now, again, if you know the algebraic way, this takes one step, but you don't know it. You know what x squared looks like graphically. Yes, a parabola. So I'm gonna let you imagine that, right? You have your parabola. What happens as you approach 1? It looks like this, right? Here's 1. What is this value right here? Oops, sorry, it should match here, right? But it should also be. Therefore, the limit as x approaches 2 of x minus 1 squared is equal to. Make sense? All right, that was a baby problem. But I wanted to show you with a baby problem that how this works, so that when it gets more difficult, you're like, oh, okay. Hold on, let me kind of look at the steps to try to make sense out of this. Okay, before I move on to something more difficult, are we cool here? Yes? What's up?
Why do you do composite function? I'm confused on that.
Say that again, I'm sorry.
Why do you do the composite function?
Why am I doing a composite function? Why not? Like, what do you mean by that question? Why am I doing a composite function?
Like, I don't know. If I look at the problem, I'm not.
Oh, like you don't think that this is a composite function?
Yeah.
Right? That's why I picked something like very baby, like, so like I could do something very simple. But I'm gonna be honest with you, I'm with you. Like, if I'm not really like, if I were to ask you find this limit algebraically, I'm not even thinking composite function either. Okay? I don't want to get ahead of myself today because that's what we're discussing next class. But at this point, because you don't know how to do things in any other way, that's why I'm looking at it as a composite function. Yes?
For the bottom one, why did you do the limit as x approaches 1 rather than the limit as x approaches 2 for x squared?
Because remember, when you're doing a composite function, you gotta put in a number to g. That g is going to produce an output. And remember, the outputs become the inputs for the other function. So because this gave you a limit of 1, then now I have to take the limit as x approaches 1, because remember, this y value becomes the x value for the outer function. Cool? All right, any other questions? Okay, so. For this one's now, let's use graphs. Okay. Can you see?
Yeah.
All right. I have two functions. Okay, so I want to know what is the limit as x approaches -3 of g of f. Cool? All right. How do you start?
Find the limit of
Okay, so find the limit as x approaches -3 from the left for f of x, and the limit as x approaches -3 from the right for f of x, which you were given graphical representations this time. So here is f. Here is -3. Is there a limit?
Yeah.
Yes. Which is
Negative.
-1. Tell me what would you write here?
-1 minus.
So this first one from the left, you're gonna say minus? Does anyone not understand why?
Because it's full.
So from the left side, I am approaching, and oops, right. From the left side, I'm approaching, and when I arrive here, I'm coming from the bottom numbers. And then logically, then the other one is plus, since it's a line, right? So I'm approaching it and getting there. Easy, right? Nothing crazy too far, like so far. Therefore, what do I say?
Limit is
Limit is
-1 of
G of X.
g of x, which now I just gotta make sure I look at the correct graph, which is now this graph. I'm looking as I'm approaching -1. -1 is here, so as I'm approaching it, I'm getting to this location, but there's a hole. Does it matter?
No.
No, because I don't care what happens at that location. I happen to care about what it is that it is approaching, which is 1. Therefore, the answer would be 1. Making sense so far? Yes, we're almost done, I promise. Two more examples and we're done. Okay? All right, next one. Now I'm giving you a graph and a function. All right. I gave you a hint. I won't give you a hint on the test, but here's a hint. How would you start this?
Find the limit as x approaches 0 of g of x.
0 from the left for g of x. Limit as x approaches 0 from the right for g of x. Right? Now, I actually know what g of x is. Let me write it instead of g of x. G of x is 1 minus x. Okay. Again, based on what we know in this class, how are you going to figure this out?
It's gonna be a reflection of the.
I heard plug in. I haven't taught you that yet. Get there.
Try to graph it.
Try to graph it. I chose something basic once again. What does 1 minus x squared look like?
Upside down parabola.
Okay,
of,
so upside down parabola with a y-intercept of 1. X-intercepts? Does it really matter for what I'm trying to do? No, but if you wanted to, you can find them. Cool? That's what it looks like. Yes? What's the limit? The limit is 1. Yes? But
From the left side, it's coming to the bottom, and from the right side, it's also coming to the bottom.
let's take this through. Here's the left side, right? As I am approaching 0 from the left side, where am I coming from? Bottom numbers and negative numbers. As I'm approaching 0 from the right side, where am I coming from? The negative numbers. They both need a negative. First example where that's happening. Therefore, what do I do that's different?
You find the limit as x goes to 0, or as x goes to
1, but only from the negative of what? F of x. So now I can use the graph. We haven't even touched the graph. Alright? The graph says, here is 1. That's what I'm interested on. As I'm approaching it from the left side, I am arriving to the number 3. Therefore, the answer to the original question, the limit as x approaches 0 of f of 1 minus x squared is equal to 3. Make sense? Super important. Let's pretend that the person that did this didn't take the time to do this part. They'll get a 1, right? And then they'll get a 1 here, right?
Yeah.
What's gonna happen?
D.
They're gonna say that it doesn't exist. You're with me? Take your time to actually check those things. Oh, any questions? All right. What I want to close out with today is I want you to try one on your own. Okay? Like I'm not gonna do anything. You try it. I'm gonna give you a graph and I'm gonna ask you 3 different limits and see if you can get them. Cool? All right. Here's the graph that I want you to utilize. And here's the 3 limits that I want you to find. What is the limit as x approaches 3 of k of x? What is the limit as x approaches 2 of k of x? And to have fun, why not? What is the limit as x approaches 0 of k cosine of x. And let me add one more for you guys. K of sine of x. Cool? I promise you I've taught you everything you need in order to try this. Cool? So take a moment, discuss them with someone next to you. Cool? And then we will discuss them in just a second. Okay? There you go. All right. Anybody have an answer for the first one? Yes. You said does not exist. Okay. Did anybody get anything other than does not exist for the first one? Let's discuss it real quickly as to why. Remember, you're supposed to first take the limit as you approach 3. So I'm looking at this, and 3 seems to be here, right? Now, I noticed that in order to get here, I need to approach it both from top and the bottom, which means I can just take a regular limit as x approaches 1. As x approaches 1, I can see that I'm approaching different values, therefore does not exist. Beautiful. Cool? Alright, does anybody have an answer for the second one? 2? Alright, let's go through that real quick as to why it's 2. As you approach 2, I'm approaching it from above, and I'm getting to 1. I'm also approaching it from above, and I'm also getting to 1. So therefore, what do I need to do?
You did take it from the
Take a limit from
right
the
side.
right side only. So, as I approach 1. So as I approach 1, which is here, the right side gets to 2. Therefore, the limit is 2. We're good? All right, third one. Has anybody tried that one?
D&E.
D&E? Okay. Well, let's discuss why. Let's see. So D and E. So for cosine, do we know what cosine looks like? All right, so real quick, I'm going to graph it. Here's cosine of x, where this value here is 1. So let's look at it. What is the limit as x approaches 0 of cosine? Well, as I'm approaching 0, I'm getting here, and I'm getting here. So the limit does exist, which happens to be 1, but where is it coming from?
Right.
From the left. That means I have to take a one-sided limit. Give me just a second. From the left of 1, I am approaching what? 1 from the left. Therefore, it is not does not exist. It is actually 1. Okay, that's all the time we have for class. So too bad if you're watching this video, you will not get the answer to that. Have a good lunch. Thank you for watching. Subscribe. Blah 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 blah. There you go.